All right, hi everyone. I'm Josh Pollock from MIT. Some of you may notice the presentation environment I'm using right now. And if not, it may become clear in a little bit. I'm going to be presenting a more theoretical talk called Language Model Agents Enable Semi-Formal Programming. And I want to start with a provocation, which is how malleable is malleable software really? So when we think about malleable software, we might think about spreadsheet environments, or maybe browser extensions, or Apple shortcuts. And what's common across all of these is that they all use programs. And programs are kind of like brick walls, right? Brick walls are nice, they're sturdy, they're rigid, they're precise, but they're also pretty impenetrable for end users. And the thing about programming is, programming is often an art of formalizing some very informal thing. So if I'm, want to make an Apple shortcut, I might start with some informal task description, for example. I want to make an Apple shortcut that creates a new note with the current date in it. And maybe this is plugging some hole in my wall, right? But then there's a very long process of sort of, breaking that task down into individual pieces, maybe coming up with some informal plan, and then gradually formalizing bits and pieces of that plan to create a final program. But the problem, with a lot of programming environments is that they have no way of understanding ideas that are in this sort of unfired clay form. And so while a user's perspective may be kind of this, where part of it is this well-defined wall, and then there's a sort of unstructured part in the middle, the view from a typical programming environment is that of the wall with nothing in the middle. And when you have this, it's impossible for your programming environment to actually help you. And projects like Hazel try to help this a little bit by essentially making sure that a wall with a hole in it doesn't fall down. But if I try to do something in Hazel like, add today's date to 2 and 3, Hazel doesn't have any notion of what today's date is, and so it can't, it's not going to blow up in your face, but it can't evaluate it either. So this is where kind of LLMs present a really interesting opportunity, which is that they let us reason about this unfired clay stage of programming. And specifically, I want to highlight kind of two analogs to how we think about programs that LLMs help us do. So one is LLMs can execute an informal specification. So for example, I can just ask ChatGPT to extract numbers from a recipe, and I'll get this nice bulleted list of numbers. Another thing that LLMs can do is essentially act as a compiler from an informal specification to a formal program. So I can just directly ask my unstructured task, like I want to create an Apple shortcut. I'll get a list of all the actions to do. Actually, I don't think I made a shortcut before this demo, but this instruction set is what I use to create this note, which essentially does exactly what you want. You take the current date, you format the date in some particular way, and then you make a new note with the formatted date. And so this gives us a capability for working over here on the left with unstructured clay. And we have compilers and interpreters which help us with this fully formalized program. But what I think is a really interesting emerging opportunity is how do we help people in this middle process, this large sort of complex process where parts of their program are unstructured and suitable for LLMs, and parts of their program are suitable for programming. And so that's why I kind of want to to name this space, I want to talk about it as semi-formal programming. It's partly formal and partly not. And to get at what this space kind of looks like, I'm going to come both from sort of the LLM side and see how we can get more formal, and from the programming side and see how we can get less formal. So the first thing I want to talk about is kind of what does it kind of look like today to sort of work within the semi-formal world. And I've kind of identified 3 interaction techniques that people use here. So I'll start with the simplest, which I call direct in the sense of like directing a model to do something. And what you'll see is within the sort of programming world, you treat an LLM as basically an API call. So this is an open source tool called LLM parser. And in LLM parser, you define this sort of structured representation of things you might want to parse. Let's say you're searching for a job. Job listings have all these sorts of different formats, but I want to know what's the job title, what's the company name, what's the location. So I define this little kind of structured representation. I have a job posting, and then I just call this parser function, which essentially internally is just saying, hey, ChatGPT, tell me the job title, the company name, and the location, and then I get some formatted piece out. So this is taking one step away from programming, where you have these building blocks of little informal pieces you can plug and play in different spots. On the other hand, we have this kind of weird space of doing a lot of things in the LLM, but kind of with more internal structure. So we often think of LLMs as doing like one call at a time, but people are exploring extending LLMs with additional tools like search, querying a database, sending messages, or even calling itself in kind of recursive ways. And I feel like it's easier to see this sort of play out than to talk about it. So I'll show an interesting demo in a second here. But this still is very much living in the unstructured world, where people often use these systems by presenting very, very unstructured high-level goals, like please learn about AutoGPT and explain it to me, or make money, or like yeah. And so I want to kind of show this demo of how people interface with AutoGPT. It has some great backing music. How do I get the audio? I need to, here we go. Is this going?
Yeah. Give it, start playing, I think that'll.
There we go, okay.
Okay.
Whoa. This is like skipping, I've seen this issue before. Does this work? Does the aux work? No. Okay. Well, I will just manually jump to the timeline, and I'll pretend that there's like cool techno music behind this. So basically, a user is working in some command line. They type in some prompt. In this case, it's like, tell me what AutoGPT is. And then AutoGPT on its own generates some list of goals. So here it's search AutoGPT, find the GitHub, figure out what it's about, explain it, and then dump it in this text file. And then the user's main interaction here is like saying yes or no to these things. And then AutoGPT has this whole like internal structure where it's like, oh, here's my plan. Now I'm going to critique my own plan. And then it can go on this loop and just keep looping forever until it thinks it's done. In my experience, sometimes it will just loop for 20 minutes and segfault, which is a really great user experience. But when it works well, it's doing this very complicated sort of unstructured thing, but internally building its own little pieces of semi-formal structure, like an internal plan, a critique of the plan, and then calling some actions for other tools. But one area that I think is especially interesting, especially for the live programming audience, is this sort of emerging middle ground, which is this very large, discussions between LLMs and users to cooperate to accomplish very complex tasks. So a few months ago, Figma announced this Genius Chat API, which is essentially this little text box that you can use to modify your Figma design. So here the user's asking to add imaginary songs, and then the Figma genius is saying, oh, so you want to add some imaginary songs to your music app. Let's create a list of songs and add them below the album information. It presents, it makes that modification, but then it also adds this little bit of structure for what the user can do next. So in addition to just this unstructured chat, it's presenting this little sort of in situ structure of like a few kind of predefined buttons. Going even further, Amelia Wattenberger just a couple weeks ago demoed this system at an AI engineering conference for building these sort of ephemeral UIs to interact with web pages. So her example was booking hotels on Airbnb and hotels.com. And essentially, given a website, an LLM and a user can interact to build a bespoke interface for working with that. So in the case of Amelia, she wanted to know how long the walk was to BART, how long the walk was to the hotel that the conference was at, and all this information is personalized in a way that like the original website is not. After a few more rounds of iteration, we see kind of more complex display with some photos extracted, but also ways to send information back to the original website through these action buttons here at the bottom. And this interface can be sort of directly transferred to a different website because under the hood, the LLM is doing the support to kind of paper over the differences in the two interfaces. So this is kind of a way where, at least from the user perspective, they're using a little bit of structure, maybe not writing the code themselves, but it's sort of relying on a mixture of traditional sort of web scraping methods and also building kind of interfaces automatically. And so this collection of systems taken as a whole seems qualitatively different. I mean, it's not a program in the traditional sense, but it's also not just an LLM. It's sort of something in the middle that has a little bit of structure. And so that's why I like to call these language model agents. They're agentic in the sense that they're interacting with the user in a particular way, but they're also sort of based on language models. And from the language model perspective, this looks like LLMs being augmented with this ability to run programs, read, write from applications, use storage. And from the code-centric view, this just looks like embedding LLMs as API calls into normal programs. So to return from this image to from before, the way that we're kind of transforming and running semi-formal programs is via these language model agents, which are exposed with these abstractions and then kind of used using these interaction techniques. But another thing we might want to consider is, how do we actually represent these semi-formal programs? And here again, we kind of see from two perspectives, like what does it look like from the LLM's perspective and what does it look like from the code perspective. So from the code perspective, this is often, you can think of as an abstract syntax tree where the leaves are some kind of unstructured data. So for example, in this parsing example, right, we have like a type here, right? It's a list of objects where each object has a name, a description, and a type, and those are all strings. But if we look a little closer at the description of this type here, the description is not just a string, it's really instructions to help the LLM. And so there's some kind of semantic meaning to the type of string that you couldn't capture in TypeScript, for example, but that has there's some sort of semi-formal structure within that. From the view of LLMs, the way an LLM views this data typically is as some kind of structured text. So LLMs can only take in text, but within text you can embed, let's say, a formal type for what you want the result to be, some informal type, so here it's like name-description, and this is some sort of like text output thing, and then some like totally informal like instructions, like, okay, pick a type if you're very confident, there may not be a type if there's no type, right? So there's this mixture of like super formal things like TypeScript types, completely informal things like instructions, and then these sort of also quasi-formal structures sort of in between. So I want to kind of close by saying, so this is sort of the state of the world as it is right now, where we kind of have the like, what is this middle semi-formal thing viewed from LLMs, and what is this semi-formal thing viewed from code? But I think there are some interesting places we can look if we want to think about stuff that's kind of native to the semi-formal world. And that's to look at semi-formal languages embedded within natural language. So one nice example of this is domain-specific jargon. So in things like medicine and law, right, there are terms like plaintiff or counsel or myocardial infarction that are precise, but maybe not so precise that they could be completely formalized in a programmatic sense. In the case of things like law, the ambiguity is actually quite useful because it lets you sort of adapt interpretations as new use cases arise. And so in some sense, this stuff wants to live in this kind of interstitial space. Another thing I find very fascinating is there's some work in linguistics on developing a natural semantic metalanguage, which is a way to kind of break down a complicated concept into these almost formal descriptions of what a word means. So this allows you to do these really precise comparisons between complex words like happy and contented by kind of breaking them down into scripts. So for example, happy could mean X feels something. Sometimes a person thinks something like this. something good happened to me, I wanted this, I don't want other things. Because of this, this person feels something good. X feels like this, right? So it's a little bit stilted, but the importance of this language is that it's kind of agnostic to different cultures and allows you to do these interesting comparisons. So the difference between happy and contented is like, instead of something good happened to me, something good is currently happening to me. Instead of I wanted this, I wanted something like this. And so by sort of unraveling one level of abstraction, but still living in the semi-formal world, we can say these very interesting things while living in kind of, in that sort of semi-formal programming space. So that's all I have for my presentation. I'm happy to take questions. Thanks.
Thanks for the great talk. I'm curious, towards the beginning, you showed two examples of LLM as a sort of direct interpreter or executor of instructions versus using it as a compiler. Yeah, that slide. I'm curious, could you say a bit more about how you think that dichotomy fits into the semi-formal idea? Because I feel like these are two quite different ways of dealing with semi-formalism, and how do you think about the trade-offs between them and moving between them?
Yeah, that's a good question. I don't think I have a fully formulated thought, but I think if I'm thinking about this picture, I think this is sort of the picture in my mind is like, at any given time, a program might live at some point on the spectrum. Well, let's see if I can actually do edits. Okay, so I might say that like doing LLM compilation is like pushing a program to the right like this, whereas like this kind of like execution thing is maybe like moving downwards in some sense. I don't know if that really answers the question. I guess one other thing to note is I think kind of like these interaction techniques is getting a little bit at somehow maybe like, I guess this is a little bit tangential to the question, but sort of like maybe what does this picture look like for that middle space? But yeah, I know it's a good question. I don't know if I totally know how to think about it yet.
Thanks.
So one idea that comes to mind is thinking about formal programming as like a theoretical endeavor where you're trying to like theoretically work out what's the code and how to formalize what you're trying to do. And informal programming as like an experimental endeavor where you're playing with LLM and exploring and experimenting with getting it to output the right things. And so I'm curious, thinking about semi-formal programming, how you could add this like experimental exploration aspect to it. I mean, I've seen some examples of this with LLMs where like tools that allow you to generate a range of inputs and see them all at the same time and pick the one you like, or tools that allow you to like maybe peel off one layer of the nodes of the LLM and modify weights at the edges of the LLM and explore the latent space in that way. And so thinking like with that conceptualization in mind, can you imagine how that could fit into like semi-formal programming?
Yeah, that's a really great point. I was just at a talk a week, I think last week, that was really showing off more examples of this kind of like generate a UI on the fly thing, specifically for ideation. So like, I think one of the examples was you have like you want to generate an image for a news article. And so you extract, keywords from the news article, you identify the tone, and then the LLM will give you like, okay, here's a bunch of words that are associated with like climate change, like, whale, fire, like, so I see that as sort of like the LLM brings a little bit of the structure, like here are a bunch of options you could select, and then the user then goes and kind of selects those things, and there's sort of like a back and forth kind of process. So I guess like, in that sense, like, I think there's some ways in which a little bit of structure, which is something an LLM can give you, allows you to like do more exploration and also eventually kind of funnel in on a particular design or a particular program.
Hi, really great presentation. I really like the sliding scale between clay and bricks. I think that's kind of how I see some of these things in my head. So I'm really pleased to see that sort of explained so clearly and with some like in a novel way. I also noticed you use TL Draw, and
Yes.
And I work at TL Draw. So thank you. I'm just curious, but you haven't like used a TL Draw within like as a library within a slideshow app. You've just used a whiteboard, which I just wonder if there's any what was the thinking behind that, and yeah, how that's gone.
That is a good question. I think it's sort of a meta thing, which is like when I was making this, like I feel like presentation software makes me live closer to the brick style of editing, and I really was not in a place where I want to commit to that style and think about like all the mini like alignment issues. And I was living over here, and then finally when I had gotten far enough, I was like, oh, the aesthetic is kind of nice, and I can like zoom in and out on code, so that's cool. And so I just kept it in the TL Draw environment.
Wait, what was the question over here? You had a question, right? Yeah.
Hey, it was a very interesting talk. Thanks. I had a question about the jargon, the domain-specific jargon thing, especially in the medical side, right? So I don't actually work on it. Okay, for disclosure, but there is this aspect very much of this kind of live interaction, especially in medical diagnostics, where there is a kind of formal-like thinking process, but the interaction is all informal and the jargon is all domain-specific, so it's not really formalizable in that sense. But by and large, what's happened is really that chat interfaces have taken off, and any flowchart or formal-like aspect has been in the background. So do you see a modality or an application where the formal side of it is up in your face for the end user in these domain-specific applications?
That's a very good question. I think one paper I love telling everyone about is Formality Considered Harmful, which really gets at some of these questions. I think what's really fascinating is like one reason why people reject formalisms is because they are living over here and they don't want to think about the formalism until afterwards. In some sense, the formalism is describing their thing post hoc. So an example was some people tried to build formalisms for argument structures. So like this is a premise, this is a conclusion, etc. And people don't think that way when they're writing the argument. It's more of like a descriptive thing. And so I think it's really interesting to think about the trade-offs between these two styles, I guess. Like, I think it's more like, yes, that's a really interesting provocation, and I think it'd be interesting to look at, well, why did they reject that? And adding formalism is not necessarily good, right? It's important to understand kind of like where it's useful and in what scenarios, I guess. I don't know is the answer.
I think we're going to see I love when a talk weaves into the next talks. We're going to see a bunch of discussion about formalism and informalism later in the sort of documents section. I think this is the first year we've had LLM talks at Live. And I know some people in this room think these things are overhyped and bogus, and some people in this room think that these things are vital and important in the future. And without asking anybody else what they think, I would like everybody in the room to give like a big thumbs up. Wait, not yet. A big thumbs up if you think LLMs are exciting and vital and important, and not great, just if you're personally really interested and enthusiastic about it, and a thumbs down if you're like, maybe it's going to be a big deal, but I'm just not that into it. And I'm really curious to get like the temperature of the room. So let's all do it together. We're going to go in 3, 2, 1. You can do like an in-between one. Yeah, I see a lot of thumbs in all directions. And I think that's awesome. Right? Like we have this like, and if you're in the chat, you could go ahead and like put some thumbs. Everybody put your thumbs up for posterity here. We'll do this again next year and see how the thumbs, someone's got a middle finger there. That's great. We'll see what this looks like maybe next year and if the opinions are changing. But it's, yeah, I think it's fascinating just to see the multiplicity of perspectives on this stuff right now, because it's obviously a very dynamic space. Maybe if you could comment just briefly on, particularly obviously being here at Live, bringing an LLM talk, your position is pretty well known, but how has that affected that both hype and enthusiasm, but also kind of like reactionary movement and controversy? Does that affect the way you're thinking about this work at all, or are you just like full steam ahead?
That's a great question. I think one thing that's really hard to disentangle is like what problems with LLMs are intrinsic to that approach or intrinsic to informal structure versus what things are artifacts of the way they work. Like what things are like artifacts of GPT-4 that will be removed by like 5 or 6 or whatever, and which things are like, oh, your task is underspecified, so you can never do this thing. I think like one thing for me is sometimes I think people try to use LLMs for formally structured tasks where like a compiler or interpreter is better. And I guess one thing for me is sometimes I use this sort of spectrum-y framework to think about like, oh yeah, like I'm fine with errors in this case where my thing is unstructured anyway. And so I kind of use that as a scaffolding to measure like, oh, this thing is overhead, this is not. Yeah.
That's great. Well, it is now lunchtime, so you can take your controversial opinions about LLMs to the lunch table. We will see you back here in 90 minutes for the next round of talks. And yeah, thanks so much again, Josh, and all the other speakers. This is a great block. Thanks so much.